Hello and welcome to Decode ISC. Today we're going to start with K-maps. Let's start from the very basics. What is a K-map? Now a K-map, which is short for a Karnaugh map, is simply a graphical way of representing a truth table. Now you might be wondering, why do we need another diagram when we already have truth tables? Because truth tables can become huge and messy very quickly, and simplifying Boolean expression using only Boolean laws can get complicated. Now a Karnaugh map simplifies this problem. Now there are multiple types of K-maps, and the most important one for the ISC boards is the 4x4 K-map. Now we have four variables, say A, B, C, and D. Right? Since there are four variables, we're going to have 2 raised to 4, that is 16 possible combinations. To represent these 16 combinations, we draw a 4x4 grid, like so, where each of these boxes represent a unique combination of A, B, C, and D. Now to organize everything, I'm going to place A and B on the left side to control the rows, and C and D on the right at the top to control the columns. Now once these labels are in place, every cell has its own identity, making it easy to locate and simplify later. Moving on to the gray code. Now this is the most important part of this whole chapter and where students lose marks unnecessarily. Now while labeling the rows and columns, your brain naturally wants to do in the binary code form. Now if you recall, the binary code goes like this: 0001 1011. But that is going to be wrong for a K-map. For a K-map, we use something called the gray code. Now gray code is a numbering system, a binary numbering system, where two consecutive values differ only by 1 bit. Let me explain. So gray code will look something like this: 0001 and then 1110. Notice how these two changes over here. Also notice how only one digit changes as we move on to the next consecutive label. From here you only see this digit changing, then we see this digit changing, and then we see this digit changing. Now if you accidentally write the labels in the normal binary code, you're not going to get your answer, it's going to be incorrect. So before doing anything else, make sure that your labels follow the gray code sequence. Moving on to numbering the cells. Now, we know, as we learned in the first part, the left side of is for variables A, B, and then we have C, D over here. Let's write the gray code next to each other. So it's going to be 0001 1110. Similarly, over here as well. Now I'm going to write the corresponding Boolean expression for them. Now just a recollection, in SOP, generally we have x for the truth value of 1 and x dash the complement for the truth value of 0. So let me write that down as well. So A dash B dash, A dash B, A B, A B dash, C dash D dash, C dash D, C D, C D dash. Perfect. Now if you remember the binary numbers, I'm going to write that down here for you. 000 corresponds to 0. 0001 corresponds to 1, and so forth. Now look into each of this box. This one, 0000, is going to represent 0, correct? Now here, 0001 is going to represent 1. Now this one, notice, 0011 represents the number 3. This one is going to be 2. Similarly, moving on to the next row, this is going to be 4, 5, 7, 6. Now this is where you need to notice we move on directly to the fourth row. We skip the third one and go to the fourth one, because this is where you're going to get 8, 9, 11, 10, right? Because 1000, when you write down the Boolean numbers, you realize 1000 represents 8, right? Oh, however, 1100 represents the number 12, 13, and then 15 and 14, and that is how you number yourself. So this is also very, very important, and it might be a little confusing at the beginning, but with a bit of practice it will become second nature to you. Perfect. Now let's do a quick question just so that we can recollect everything. This is a question for SOP. So the question is f of A, B, C, and D is sigma of 057. Now sigma represents min terms, or SOP, sum of products. Perfect. Now let's quickly number this as we did in the previous slide. 7, 6. Moving on to the fourth one. Oh, my bad. Let me do that again. Yeah. 11, 10, 12, 13, 15, 14. Now our job is very, very simple. What we do is we look at which cell contains the number 0 and then we place a 1 there. Okay? Then we check which cell has 5. We place 1 over there. Similarly, 7. Now in the remaining boxes, we fill them up with 0. Now what we've essentially done is we've simply transferred the information from this question to the form of a K-map. We haven't done anything else, right? And that is how you fill your K-map, the first step to doing the question. Now comes the next step, grouping. The goal of grouping is to simplify our K-map. But before we do that, we need to know a couple of rules. The first one states that groups may not include any cell containing a 0. Now what that means is when I'm creating a group, I can create a group like this. I can also create a group like this. But I cannot create a group like this. The reason being, when I'm creating a group, I cannot have a 0. Nor can I create a group like this. Why? Because it contains a 0. So that is the first rule. Moving on to the next one. Groups may be horizontal or vertical. Now what does that mean? I can create a group like this. I can create a group like this. However, I cannot create a group like this. Why? Because this is not horizontal or vertical. This is diagonal. That is wrong. I can't create a group like this because again, this is not horizontal or vertical. Very simple, right? Next one. This is very, very important. Groups can contain only 2 raised to n cells. Now n here is a natural number, right? Now when I say 2 raised to n, what do I mean? The numbers that come are going to be 2, 4, 8, 16, and so on. Now what I mean by that is simply this. I can create a group like this because this has 2 cells. That works. I can create a group like this because that contains 4 cells. That is also correct because that is also part of the sequence 2 raised to n. However, I cannot create a group like this. Why? Because that is not part of my 2 raised to n sequence. Nor can I create a group like this because 1 is also not part of my 2 raised to n sequence. Okay, that's a very, very important rule that you need to remember. The second part of the rule says octets, 8 cells, have greater priority than quads, 4 cells, and which have a greater priority than pairs containing 2 cells. What that means is when I'm starting to group, I need to first check for all the octets. Now in this particular question, there are no octets. Now we can move on to the quads. So here we have a quad over here, another quad as such, another one is going to be over here. Now that I've found all the quads that I can, these are the maximum number of quads I can find, I can move on to the pair. Now there is one pair over here, and that's how I use this rule to simplify a Karnaugh map. Now this one is also something that you might have understood so far, is that groups may overlap. What that means is when I'm creating a group like this, I can also create another group like this. Simply because these groups overlap does not make them not correct. It is correct. You can overlap groups. That is what this rule means. The next rule. Groups may wrap around the table. Now look carefully into this question. Do you see any octets? Notice if I do this, I would get an octet. Now what that means is instead of visualizing a K-map as simply a flat piece of paper, imagine it to be a sphere where these corners touch each other. So I can do this wrapping. This is what is wrapping. I can do this in order to get my largest group. Similarly, I can also create a group like this. Right, this is another octet. Now, for example, if I'm going to take an example for a quad, I can also do like this. This is a valid quad. Obviously, since here we have our ones, you cannot do that in this question, but you could do that in other questions. Another example for pairs could be like this. Right, this is what this rule states. The next one is a quick example that we're going to do, similar to the one that we did earlier, but this time we're going to group it. So first step is we write down our cell numbers 8, 9, 11, 10, 12, 13, and 15, and 14. Perfect. Now what we do is we write one corresponding to each cell number given here. So 1, 1, 1, against 4, 5, 6, 8, 9, 10, 12, 13, and 14. The other areas, we're going to put a 0. Now, what is our first step when we're doing groupings is we need to prioritize octets over quads over pairs. Now, in this particular question, we first look at octets and we can form this octet over here. Another octet that we can form is this one right here. And so that's it. We know we can start with our grouping when we realize that each one is in some group. There is no lone one anywhere. Every single one is present in some group, and that's how we know we're done with our grouping. Now we're moving on to the reducing Boolean expression in SOP using K-map. The essential idea why we're using K-map is because we need to reduce Boolean expressions. For that, we need to remember one very important set of rules, and that's simply this. Octets eliminate 3 variables, quads eliminate 2 variables, pairs eliminate 1 variable. Now, it might not make sense right now, but let me just go to our question, and then maybe you can make sense out of it then. Now, this is the same example that we did previously, and if you remember, we created a group like that. Another group that we created was like this. Now, if I'm going to write down my cell numbers 7, 6, 8, 9, 11, 10, 12, 13, 15, 14. Now here's what I'm going to do. I'm going to write my octet 1. Before I do that, remember how we wrote 0, 0, 0, 1, 1, 1, 1, 0, and then we wrote A dash, B dash, A dash, B, A, B, A, B dash, and then similarly we did that here as well. This again was in the first set of slides that we did. C dash, D dash, C dash, D, CD, and CD dash. Now the first quad is going to be the one in red. The first octet, the first octet is the one in red. Now what I'm going to do is I'm going to write down the corresponding Boolean expression for each of these cells, right? So if I'm taking this first cell 0, what's the Boolean expression for that? A dash, B dash, C dash, D dash. That's for 0. For 1, it's going to be A dash, B, C dash, D. A dash, B dash, C dash, D. For 4, it's going to be A dash, B, C dash, D dash. For 5, A dash, B, C dash, D. For 8, it's going to be A, B dash, C dash, D dash, A, B dash, C dash, D, and then A, B, C dash, D dash, A dash, B, C dash, A, B, C dash, D. So what we've done is simply written the Boolean expression corresponding to each of these cells. Okay, now what we need to do is we need to eliminate the complements. So what we're going to do is we're going to take any two expressions, right? And we're going to eliminate any complements that are there. Now complements as in x, the complement of x is x dash, right? So if I find the complements, I'm just going to eliminate them. Here, in this particular example, if you notice, there's D dash and D. So I'm going to eliminate them. I'm just going to cross them out. Okay, now look at, say, these two. Now, D dash and D again. Next, D dash and D. The other pair, D dash and D. right? And you can take any combination you want. Okay, let's take, say, this one and this one. We can eliminate b dash and b. Similarly, if you take this one and this one, we're eliminating b dash and b, right? This one and this one, similarly to this one and this one, we do the same thing again. B dash b, b dash b. Perfect. Now what I can do is I can take these two. When I compare them, I can eliminate a dash a, comparing these two, a dash a, then these two, and also these two, we can eliminate a dash a, a dash a. Now if I'm going to do one last step and check if I can remove the c dash anywhere, if I can find a c, I can't, right? What I realize is I'm left with a c dash, right? And remember how I said in the previous slide, octets eliminate 3 variables? Look at what had happened. We started off with 4 and we eliminated 3 to give our final 1 variable c dash. Now that's how you simplify. Now if I'm taking the second octet, which is the one in blue, and you can try that for yourself, what you will see is that you're going to be left behind with a single one. This is for the second octet. I'm just going to write that here. We're going to be left eliminating 3 variables. You're going to be left with d dash, right? Now here's the final expression. We have simplified octet 1 and octet 2 to give c dash and d dash. The final simplified SOP is going to look like this. C dash. Now because SOP is sum of products, we add to the other one d dash. And this is our final answer. And that's simply how you do simplification of a Boolean expression of Karnaugh Maps for an SOP. Now for POS, it's going to be a little bit more different, and we'll discuss that in the next video. Thank you so much for joining. This is Decode ISC, and I'll see you in the next video.